Hello everyone, and welcome to the second part of the videos on limits. And today we're going to look at this problem, and we're going to start with the function, which this one happens to be 1 over x squared. And here we're going to ask ourselves, okay, well, what is the left-handed limit of this function? What is the right-handed limit of the function? And also, what is the limit as x approaches 0 for this f of x being or 1 over x squared. So now in the previous video, if you haven't watched it, I recommend you do go over what limits are and whether they exist or not in the definitions. But here, in the previous lecture, we talked about a function as it approaches a number having a number L, right? Approaching some number L, right? But here, as we observe, as x approaches 0 from the negative side, you'll see that the function just keeps increasing and increasing, right? So there isn't a number necessarily that it is trying to settle onto. So what do we do then? Do we just say that the limit doesn't exist, that we can't take the limit? Well, in this case, the limit would still exist, but what we name that behavior, right? If it keeps increasing forever, we just say that the function, as x approaches 0 from the negative side, we'll say that it's going to approach this concept of infinity, because it's not a number, but we just say that it's approaching infinity. Right? Now, same thing here, if we approach a limit from the right-handed side, as it approaches an origin or 0, it would also increase and increase, which would make it infinity as well. Thus, the last thing to remember from the last lecture, for a limit to exist at any number a, in this case 0, the left-handed limit and the right-handed limit have to be the same and exist. In this case, they are the same. So we're going to say that the limit as x approaches 0 is also infinity, right? All right, simple enough. I'm going to go to another problem here really quickly, and then we're going to explore a little bit some different scenarios that can occur as well. All right, so here's the next problem. Now we change the function to a 1 over x function, and we're going to still go over the exact same questions and see what happens now, right? Okay, so let's start by the left-handed limit. As x approaches 0 from the left side, as you can see now it's decreasing all the way down, right? So it's kind of going to this infinity, but there is two different kinds of infinities in this case, right? There's going to be a positive infinity and a negative infinity. Since this function is decreasing as we get closer and closer to 0 from the left side, then we say it's going to approach this negative infinity concept, right? So we cannot put positive infinity or regular infinity because it's not increasing. So here, you'll say that instead of it being positive, it's going to approach a negative infinity, right? It's going to keep decreasing. And now the limit is going to look very similar to the last problem, 1 over x squared. The right-handed limit here would be a positive infinity, right? Because it's going to keep increasing as we get closer and closer to the origin. Okay, but now if I ask you, what is the limit as x approaches 0 here of this function 1 over x? Well, since the left-handed limit is negative infinity and the right-handed limit is positive infinity, the limit as x approaches 0 would not exist because they're not the same, they're not approaching the same concepts here, therefore there is no limit at that point, right? So we would say that it does not exist at this point. Okay, so that's pretty simple. So now we've gone over what happens a little bit when these x values approach a number and we're getting these like what we call a vertical asymptote, right? They're approaching these positive and negative infinities. Now in the next problem, we're going to go over some scenarios. Well, let's say when x is approaching an infinity, right? Because it's positive infinity or negative infinity. So I'm going to quickly set up that problem and then I'll come back. All right, so now I've set up this problem, and now we're looking at a function e to the x, the exponential function, right? So here, we're going to look at two behaviors. The limit as x approaches positive infinity and the limit as x approaches negative infinity, right? Here, we're going to basically just care about the end behavior of our graph, right? So we don't really care what's happening in the middle. It can do like a lot of waves. It could increase and decrease. We only care about the tail ends of the function, right? Because we're basically just seeing what the behavior of that function is at those instances. So here, if we take the limit as x approaches positive infinity, if you notice the graph of e to the x, it's an exponential growth. So it's going to keep growing and growing, right? So if we keep increasing this x value over and over and over again, really follow it, the function is going to keep increasing, right? So if the function increases, as we increase our x value, and it's not settling, we're going to say that the function is going to approach positive infinity, right? That's pretty straightforward. But let's say now we want to approach the limit as x approaches negative infinity. So as you can see, the function tends to decrease, right? But it doesn't really like to cross that x-axis, right? It kind of wants to settle down to that y equals 0 line without touching it. So what we're going to say is that limit, as x approaches negative infinity, it's actually going to approach that y equals 0 line, or it's going to approach the value of 0, right? Because we're getting closer and closer toward that line. All right, so let's take this function, let's say 1/2 to the power of x, right? Another exponential, but now it's an exponential regression, because if this number is between 0 and 1, the function is just going to decrease as such, right? So now, as we approach positive infinity for the limit, now we're going to approach that 0 value again, right? It's going to keep approaching 0 without hitting it all the way down. So we're going to say it's going to go approach the 0 number. And now, if we take it from the negative side, as x approaches the left side, or negative infinity, right, the end behavior is going to keep increasing. Even though it's approaching negative infinity, the function still increases and increases. So we're going to say that the function approaches is positive infinity still, right? So that's kind of the idea of it. But let me show you one last problem. That'll be the last one we're going to go over, and I'll be right back. All right, so now let's examine this graph and this function, right? And the behavior that it's doing at positive infinity and negative infinity. Like I said, we don't really care what it's doing in the middle, right? That can do whatever it wants. We just care about the end behavior. So if you go to positive infinity of this function, right, as you can see, it's trying to settle and settle and settle onto this positive 7, right? That's y equals 7 line. So as we get closer and closer to infinity, positive infinity, the limit of this function is going to approach that number 7. Now, if we take that limit as x approaches negative infinity, the function here is trying to settle back down to that 0 again, as we saw the other two functions do the same thing. So we're going to set the f of x, that the limit as x approaches negative infinity of f of x is going to approach that 0 line. So sometimes here, when you have end behaviors, you can have the limit be positive infinity, negative infinity, but you can also have that end behavior be physical numbers that it tends to approach. We call those horizontal asymptotes. So like you see here, this y equals 7 and that y equals 0. So essentially what this is happening now is that this function is squeezed between these two values. So this function will never go past these values at all, even if you stretch it all the way to positive infinity and negative infinity. All right, so hopefully that covers a little bit about the basics on the limits as they approach infinities and negative infinities, and the limits as they approach numbers being infinity and negative infinity, right? Hopefully that helps. If you have any other questions, you'd like me to explain things differently, please leave a feedback in the comments down below. Like and subscribe, and if you have any other questions, please let me know. But it's been your boy Brisk, and I'll see you guys in the next video.